Simon here from Harvey CS5X, and today we're going to be talking about a very important topic, and that's recursion. So, what is recursion? Recursion is the concept of taking a problem we want to solve in computer science and breaking it down into similar problems that are a little smaller, and continuously doing that, breaking it into smaller and smaller and smaller problems until we have a smaller version of that original problem that we know the answer to. We can think of breaking down our recursive problem the way we might think of taking apart a set of Russian nesting dolls. Let's start with our biggest problem, or in this case, our largest Russian nesting doll. When we take it apart, we have a smaller Russian nesting doll, which resembles our biggest one. In the same way, when we break down our largest recursive problem into the next one, it'll be a little smaller, but look quite similar. We continue breaking down our Russian nesting dolls into an even smaller one, and an even smaller one, until we arrive at the very smallest one, or in other words, our very simplest problem. A problem whose answer we already know. Let's define this simplest problem as a base case. And afterwards, once we've arrived at our base case, we can now rebuild back up through our recursive steps to find the answer to that second smallest case, and then our third smallest case, until we finally arrive at our largest case. And now we've rebuilt back up to our largest Russian nesting doll, or in other words, we've arrived to the answer to our original large problem. We'll get to coding recursion soon, but for now, let's look at a more concrete example. We're going to inspect something that you may have encountered before called the Fibonacci sequence. To form the Fibonacci sequence, we can start with the first two numbers in the sequence, 0 and 1. To get any next number in the Fibonacci sequence, you simply add the two numbers in the sequence before it. So the third number in the sequence is also 1 because 0 plus 1 is 1. Next, 1 plus 1 is 2. 2 plus 1 is 3. Then 3 plus 2 is 5. 8. 13. 21. And so on. We can represent the Fibonacci sequence recursively. Let's do this by using what we call our base case, in other words, our simplest problem, and a recursive step. So, for the Fibonacci sequence, there are actually two base cases. They happen at the 0th index and the first index. So, we say that f of 0, the 0th number in the Fibonacci sequence, is 0. And the first number in the Fibonacci sequence, f of 1, is 1. Now that we've defined our base cases, let's think of a way to define a recursive step so that we can break down any problem into smaller problems and smaller problems until we get to our base cases, f of 0 and f of 1. So, for some number n, we know that in the Fibonacci sequence, it will equal the sum of the two numbers before it. We can think of the number before n as n minus 1, and the second number as n minus 2, and we know that f of n will be the sum of those two numbers. We've now defined our base case and a recursive step, and at this point, I think that we can find any number in the Fibonacci sequence using both our recursive step and our base cases. Let's take f of 4, for example. F of 4 is not 0 or 1, so we need to use our recursive step to find the answer to the problem. We know that f of 4 will equal f of 3 plus f of 2. F of 3 and f of 2 are also functions in the Fibonacci sequence that aren't our base case. So we need to break down this problem into an even smaller problem the same way we did with our Russian nesting dolls earlier in the video. So f of 3 equals f of 2 plus f of 1. And we know that f of 2 will be f of 1 plus f of 0. And now we've represented f of 2 in terms of our first two base cases, f of 0 and f of 1. So now we can start solving for f of 4 by building back up to the top. We know that f of 1 is 1 and f of 0 is 0. So therefore, f of 2 is going to equal 1 plus 0, which is 1. We now know f of 2 and f of 1, which was our base case. So, f of 2 is 1, we found over here. F of 1 is 1, which we know from over there. And now we know that f of 3 will equal 2. Finally, to find f of 4, which was our largest problem, we simply substitute for f of 3 and f of 2, which we both already solved for, to finally find that f of 4 is simply 3. In short, recursion is simply the process of taking our largest problem and breaking it down into smaller and smaller problems until we arrive at what we've defined as our base case. We get down to our base case using what we define as a recursive step. In the next video, we'll learn how to define a base case and recursive steps in Python code.